Alright, here's another tutorial for you coming from Mr. Stewart. I'm looking at RM2, which is all about how to balance reactions. To tie this into some of the other learning targets from this unit, these two substances here, aluminum and oxygen gas, are the reactants, and this substance here, aluminum oxide, is the product of this reaction, because this is what you're left with after these two substances react and combine here. The point of balancing a reaction is that we have the same atoms on this side that we have on this side, because RM1 says that atoms can't be created or destroyed. So unless you have the same number of aluminum and the same number of oxygen atoms on the left side as the right side, something is screwed up with our chemistry. And remember, we can't mess with subscripts. These chemicals are fixed by nature. We don't get to choose how many aluminum and how many oxygen atoms combine to make a substance. That's fixed by the charges. So going all the way back to the last unit, aluminum is a +3 charge, oxygen is a -2 charge. So I need 2 plus 3s. And 3 minus 2s. -2. That equals a +6 and a -6. So those are balanced and our charges are equal. So the whole point is we don't get to mess with the subscripts. The only thing that we can change, this is super important, is the coefficients right here. And when we change those numbers, we don't just add the one piece of this puzzle that we want, we add every bit of that piece. So if I'm going to diagram out what 1, 1, 1, 1 looks like for all of my things, if I just pencil in a 1, a 1, and a 1, what I would end up drawing looks like this. A-L, O-O, A-L, A-L, O-O-O. So we know I have right now 1 aluminum versus 2 over here. So that's not going to work. So I got to change this. Again, we're just penciling this in. It's just a guess and check kind of thing. Change it to 2, which means now I have Al, Al. So my aluminums are good right now, as of right now. 2 aluminums on this side, 2 on that side. So I'm not creating or destroying any aluminum atoms right now. But the big issue here is with my oxygen atoms. I've got 3 on this side and 2 on this side. So if I change this, it'd be really nice if I could make this like 1.5. But I can't do that. I can only add a whole second one. So if I pencil that in as a 2, now I've got OO, but I'm still not any better off because now I've got 4 on this side and 3 over here. So I need to add another oxygen on this side to balance it off. But again, I'm unlucky because I can't just pick the part I want. I can't just steal that and call it a day. Now, I also need to add the whole rest of this puzzle here, even though I don't want most of this. And I have to change the coefficient here to a 2. So if I had 2, 2, 2, that's what this would look like. And it's still not balanced now because I've got 2 aluminums on the left and 4 on the right. So I need 2 more of these. Which means that's now 4. I'm getting closer. My aluminums are good again, but my oxygens are still screwed up. I need 2 more oxygens on this side, which means this has to be a 3. So my final answer for this question would be 4, 3, 2. I need 4 aluminums, 3 oxygens, 2 aluminum oxides. And again, this is all kind of built on that one unit that we did earlier. I think it was like BC5, where you had to interpret a chemical formula. So when you see Al2O3, you know that means 2 aluminums, 3 oxygens. And I had you all draw it out in class before this whole coronavirus stuff started. Hopefully that's helpful. I'm going to put a bunch more of these on here just to give you a lot of examples to draw from.